Hey, welcome back to your favorite Fundamentals of College Math class. We're going to look at expected value today. We're going to compute that and use those concepts to solve some applied problems. So, what is expected value? So, it's a mathematical way to use probability to determine what to expect in various situations over the long run. That's what you want to remember is over the long run. Okay. So it's used to determine premiums on insurance policies, weigh the risk versus benefits and alternatives, business ventures, and then indicate, like in gambling, what will happen if the game is played repeatedly. So if you're playing like we'll talk about a roulette situation today, if you're playing that game each time, in the long run, are you winning or losing money? Okay. So expected value. To compute expected value, what you do is you take the outcome times the probability, and then you add it to the outcome times the probability, and you repeat this. Whoops, plus dot dot dot. Okay, so it's outcome times probability, outcome times probability, and sum those up. That's how you figure out in the long run what's the return on my investment, if you will, for playing a game of gambling, for example. All right, let's do a simple scenario here first. Find the expected value for the number of girls for a family with three children. So if you're going to have three children, what's the expected value for the number of girls? And if you notice, you could have zero girls. If you're having three kids, that means you'd have a boy, boy, and boy. You could have one girl situation would be if you had a girl, then a boy, boy, or maybe you had a boy first, then a girl, then a boy, or maybe you had a boy, boy, and then a girl. So that's all the situations. If you're having three kids, that's all the ways that you could have one girl. How about two girls? You could have girl, girl, boy. You could have a girl, boy, girl. You could have a boy and then a girl and then a girl. Those are the ways that you could have two girls. How many ways, if you're having three kids, could you have three girls? There's only one way. You have a girl, then a girl, then a girl, right? So it looks like we got 8 ways here, right? These are 8 ways to have kids. So the expected value of girls, if you're going to have three kids, we consider each situation. So 0, this is the outcome. So we take the outcome times the probability. And then we take the next outcome times the probability and we repeat this plus dot dot dot. So first we're going to go 0 girls. The probability of having 0 girls, 1 out of, notice there's 8 ways to have 3 kids. So 1 in 8 probability I have 0 girls. I could have 1 girl. That's the outcome. I have 1 girl. How many winners are there? 3 out of the 8. There's 3 out of 8 ways. 8 ways to have 3 kids. I could have plus, I'm going to go down here, 2 girls. Now there's 3 winners out of 8 ways to have 3 kids. And finally, the last outcome is I could have all 3 be girls. And there's 1 way to have 3 girls if you're having 3 kids out of 8. So your probability is 1 in 8 that you have 3 girls, right? So we have 0, 0 times an 8, we get 0. We got 1 over 1 times 3/8, we got 3/8. We got 2 times 3/8, so we got 6/8. And we got 3 times 1/8, so we got 3/8. So it looks like we have, what is that, 12/8 or 3 halves or 1.5. So what does that mean? We just found that's the expected value. If you're going to have 3 kids, that's the expected number of girls you're going to have. You're like, well, of course. I'm gonna have three kids, my expected value is 1.5 girls, right? Half of them. But that's just saying in the long haul, right? We just wanted to run through the mathematics of an expected value. Expected value when you have three kids, expect to have 1.5 girls, right? Of course, you can't have a half kid, but mathematically speaking, the expected value. All right, how about this situation in determining insurance premiums? So you've got this automobile company has determined the probabilities for various claim amounts. So the probability of these drivers ages 16 through 21, the probability in that year of them claiming nothing is 70%. But the probability of having a $2,000 claim for these risky drivers is 15%. Probability of having a claim for $4,000, 8%, and so on, right? So what's the expected value here? So again, we take the outcome. The outcome is a $0 claim, and then we multiply it by its probability. Now we don't have to figure out the probability here. It's already given, so times 70%. Plus, the next outcome is maybe a driver in that year has a $2,000 claim. It's a 15% probability that happens. The next outcome is they have a $4,000 claim. 8% risk probability that happens in that year. You have a $6,000 claim. 5%, $8,000 claim, 1%, and a very expensive $10,000 claim, 1% as well. And then you punch this in. So 1,100. Okay. So what does this mean in terms of insurance premiums? This is saying in the long run, the average cost for these drivers for the year is $1,100. Right? If I'm taking in all these drivers and here's their claims and the probability that they have a claim for whatever amount, okay, the average cost in the long run for all these drivers is 1,100 bucks. So just to break even, just to be able to meet the claim part here, they got to charge $1,100 per driver for the year to meet just to break even, right? Of course, they're going to have other overheads, so they're going to have to charge more than that for those drivers in a year. But that's what it's saying, right? In the long run, the average cost of a claim for those drivers ages 16 to 21 is $1,100 in that year. All right. To find the expected value of a game, do the same thing. We're going to take the outcome to multiply it by its probability. So the outcome of winning times its probability plus the outcome of losing times its probability. Um, so let's say we've got roulette here, and we're going to bet $1 on the number 20. So we got to hit the number 20 on the roulette wheel. If the ball lands on the number, you get $35. And you get to keep the dollar. So it's kind of like you paid $36, but you still hand them the dollar. So the outright winning is $35. Okay. If the ball lands on any other slot besides that number 20, you just lose your dollar. So what would the expected value be of playing this game? Well, if we win, so the one outcome is we win. What do we win? Net? We net $35. What do we lose? Or I'm sorry, we'll do lose over here in just a second. That's our other outcome. That multiplied by its probability. What's the probability of winning, right? We got to hit this number 20. How many numbers are there? If you remember, there's 18 red slots, there's 18 black slots, and there's 2 green slots. So there's 38 total, 38 slots total. Okay. So we have a 1 in 38 is our probability of winning, of hitting that number 20, that black number 20. We have a 1 in 38 chance, okay? What's the probability of losing? Well, any of the others are a loser. So 37 out of 38 is a losing, but we only lose $1. We lose $1. Okay, so we multiply this. We got 35 out of 38. And this is minus a 37 out of 38. So we got negative 2 out of 38, or negative 1 in 19. That's negative 0.05263. I'm going to round it to the nearest tenth since we're working in dollars and cents here. So that is a loss. So this expected value is a loss of 5 cents. So what is this saying again? This is saying, you want to remember it, with expected value. In the long run, each time I play, I lose 5 cents. So if I was to play this thousands and thousands of times, because I'm approaching my theoretical probability, as my empirical probability approaches the theoretical probability, each time in the long run, as I play this thousands of times, I'm just losing 5 cents every time I play it, right? The more I play it, the more I approach that expected value, right? Because the closer I get to my theoretical probabilities. So, what does this teach us about gambling? Well, you got to realize that games in gambling casinos, they're set up so that your expected values are always negative, right? They do that. They try and entice you with, oh, it seems like this is winnable, right? Sometimes I win, sometimes I'm losing. Their expected values are going to be negative, meaning the house always wins. In the long run, as we get a bunch of these players playing our games, every time they play, the house, the casino, is winning 5 cents every time they play. Right? That's how they build those big old buildings, etc. Thanks so much for listening. That's expected value. See you guys next time.